7.4b, areas of triangles and quadrilaterals. This is a little bit of review, these first three problems. Draw a figure with appropriate markings and find the appropriate length. Find the length of an altitude, or a height, of an equilateral triangle with perimeter 15. So if I draw my best equilateral triangle, those two sides are congruent, and if you draw the altitude straight down, that's going to mean that these two lengths are congruent. I didn't draw that very good, but those two lengths should be congruent. So that means that all three sides are the same length. So if I take 15 and divide it by 3, that means each side length is going to be 5. And these two side lengths, that whole side is 5. So this is going to be 2.5 and 2.5. And one last thing that I need to put on there is when you draw an altitude, it comes down at a 90-degree angle, and we're trying to find that height x. So really you just pick one side to focus on, and we're going to use the Pythagorean theorem to help us get the third side. 2.5 squared plus x squared equals 5 squared. 6.25 plus x squared equals 25. X squared equals 18.75. Square root of both sides, and x is going to be approximately 4.33, or the altitude is approximately 4.33. Find the length of a diagonal of a square with a perimeter of 36. So there's my square. All four sides are congruent. So 36 divided by 4 gives us each a side length of 9. 9. And I'll do another one down here, 9. And we're trying to find the length of the diagonal, where this is a square. So again, Pythagorean theorem, 9 squared plus 9 squared equals x squared. So that's 81 and 81, so x squared equals 162. So then x is approximately, take the square root, 12.73. Okay, last one. Find the length of the altitude from the vertex connecting two congruent sides of an isosceles triangle with a base of 12 and a perimeter of 28. So here's my picture. These two lengths are congruent. If I bring this down, then these two lengths are congruent as well, which is going to be a 6 and a 6, because that's my base. So then if I do 28 minus 12 divided by 2, then those two side lengths are both going to be 8. And again, it's a 90-degree angle, and we're trying to find that height of x. So then 6 squared plus x squared equals 8 squared. 64 minus 36, 28. So x is approximately 5.29. Okay, now thinking about what we learned last class, three-dimensional graphing here. They provided us a three-dimensional figure here. It's a rectangular prism. Give the coordinates for each, then tell where the point is located. So we'd like to know about T right there. I can see that it's along the x-axis, and it's along the x-axis at 1, 2, 3, 4. So it's got an x-coordinate of 4, but it's nowhere on the y or the z, so 0, 0. It's on the x-axis. All right, V, I can see V is over there on the y-axis at 1, 2, 3, 4, 5, 6. So no x's, 6 on the y, and none on the z. It's on the y-axis. Finally, R. I can see that R is going straight up from V, so it's going to lie on the YZ plane. So I can see that it's not going to have any x value along it, so no x. And then it's going to be the same position as V, so right 6 on the y-axis, and up 3 units on the z-axis. It's on the YZ plane. All right, another review from last class. Find the coordinates of the midpoint of the segment with the given endpoints and find the length of the segment. Remember, length The synonym for length is distance. So anytime it's asking for length, you're going to use the distance formula. So midpoint first. So midpoint is the average of the x's, y's, and z's. So 1 plus 8 over 2, 3 plus 0, over 2, negative 4 plus 4 over 2. So that's going to be 9 over 2, which is 4.5. 3 over 2, 1.5, and 0 over 2, 0. So there's the coordinates of my midpoint. And then we're going to find the distance. I'm going to do it in order of x, y, z. I'm going to go right to left, so 8 minus 1, 0 minus 3, 4 minus negative 4, 4 plus 4. So then 8 minus 1 is going to be 7 squared. 3 squared, negative 3 squared, but I'm going to go ahead and just write it as 3 squared since I know it's going to turn out positive. And then 4 plus 4 is 8 squared. So it's going to be 49 plus 9 plus 64, which is the square root of 122. And you can leave it just like that. We're just practicing using the formula. Sometimes if you can reduce, you can simplify that radical. All right, let's practice using three-dimensional drawing. We're going to decide whether this, tell whether the given coordinates form a triangle that's isosceles, equilateral, or scalene. We've got 3 coordinate points, and we're going to graph it on this graph paper. So if you are at home and you don't have this note sheet and you would like to practice graphing on three-dimensional graph paper, you can Google this type of grid. It's called an isometric grid paper. Isometric grid paper allows you to do some three-dimensional drawings, three-dimensional graphing on a provided grid. So what you're going to do, I'm going to switch to a highlighter here because what's going to happen is that you focus on your x and y coordinates first, and then you finally do your z coordinates. So you're going to either go to the left or the right on the x-axis, then the left or the right on the y-axis, and finally you finish with your up and down. So similar to Cartesian, but in the third dimension. So let's plot A first. So A is going to be 5, the positive direction on the x-axis. So from 0, we're going to go 5 positive. 1, 2, 3, 4, 5. So there's 5 positive on the x-axis. Then you want to go 3 on the positive y-axis. So 1, 2, 3. So what happens is that you can connect those up to make a plane on the XY plane. You see that? And I can even fill it in, but I won't, but there is my XY plane connection between 5 on the x-axis and 3 on the y-axis meet right there at that corner point. So then what you do is you go from this corner point to go up or down. So the first thing you need to do is find that corner point intersection between the x and y axis, and then you can use this vertical line to go up and down on the z. So in this case, we want to go 4 positive on the z. So 1, 2, 3, 4. So our A coordinate's going to land right there out in three-dimensional space. All right, let's do another one. I'm going to switch to yellow to help me with my x and y plane. So we want to go 8 on the x and 8 in the x, 8 in the y, and then we're going to go up 11. So let's count it out. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 6, 7, 8. Then you can draw a straight line from those and find their intersection. Because it's 8 and 8, it should meet on the z-axis right there. They're your intersection. And then we're going to count 11 up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it lands on the z-axis right there, 3 up from the origin, and that is our B. And then finally, we're gonna do our C. So we wanna go 4 again on the, or 4, it's less than the 5. So 4 on the x-axis, 1, 2, 3, 4. And then -1 on the y-axis, we haven't gone negative yet, so negative is this direction. So see that square there? It's the other direction. So this is my intersection between the two. And then we want to go 8 up. So 1, 2, 3, 4, 5, 6, 7, 8. So there is our triangle sitting out in 3-dimensional space. It's kind of turned, so you can see it's not lying on any plane. It's kind of laying down, but floating out there in 3 dimensions. And we'd like to know if it's scalene, equilateral, or isosceles, and we use lengths to determine that. And remember, the synonym for lengths is distance, so we're going to find the distance of all 3 sides and compare. I'm not going to go as slowly as I did on the previous problem. I'm just going to start doing the subtraction in my head and moving forward. So if you need to write it out, but I'm gonna move a little quicker on this one. So AB. So 8 minus 5 is 3 squared. 8 minus 3 is 5 squared. 11 minus 4 is 7 squared. 9 plus 25 plus 49 is, I'll write it out, plus 25 plus 49 is the square root of 83. All right, let's do BC second. 8 minus 4 is 4 squared. 8 plus 1 is 9 squared. 11 minus 8 is 3 squared. So that's going to be 16 plus 81 plus 9 is the square root of 106. And then AC, that's going to be 5 minus 4 is 1 squared plus 3 plus 1 is 4 squared plus 8 minus 4 is 4 squared. That's going to be 1 plus 16 plus 16 is the square root of 33. So if we compare these 3 lengths, we can see that this is scalene. None of the lengths are the same. Okay, moving right along. The top of the notes here is just to show you what the formulas are for finding different triangle and quadrilateral areas. These are ones that you should memorize, put to memory. Some of them are potentially going to be provided to you on an SAT or ACT, but maybe not all of them. So it would be wise to memorize these formulas. The B's stand for bases, and bases, like for example on this trapezoid, the base 1 that they're talking about, base sub 1, is that top shorter length, and the base sub 2 is that entire long length on the bottom. So just keep in mind that's what that means. And then kites, you'll see D1 and D2 sometimes in a textbook, and that means the diagonals. So this is the short diagonal and the long diagonal for a kite. So we're going to try this example. Find the area of the polygon. So this whole length is 9, so I know that that's going to be my base 2. And then I need to know what my base 1 length is. And I know this length is 3, but I am unsure about this length so that I can subtract it and figure out the top length. So this is going to be a missing value that we have to find. And then also we need our height, and the height is also a missing value we need to find. So in this picture, really you're thinking about 2 different triangles going on here. We're going to use Pythagorean theorem to help us get our height. So it's going to be 3 squared plus x squared equals 5 squared. We've got 9 plus x squared equals 25. X squared equals 25 minus 9 is going to be 16. So x equals 4. So our height equals 4. And that 4 helps us get the missing length on the second triangle to get that little short length. So we've got 4 squared plus x squared equals the square root of 17 squared. 16 plus x squared equals 17, because those square root and square cancel. X squared equals 1, so x equals 1. So that length right there is 1. So if I do 9 minus 3 minus 1, that leaves me with this top length, this length, to be 5. So now we can find our area. So our area is going to be base 1, which is 5, plus my base 2, which is that long length of 9, divided by 2, times our height, which we calculated to be 4. So that's going to be 14 over 2 times 4, or 7 times 4. So our area is 28 units squared. Okay, our final one. I do encourage you to pause this and practice graphing it. I am not going to graph this one on the video, but I will post a picture of the graph finalized. So this is a good practice for you to graph it. What we'd like to do is classify the polygon as much as possible and find the area. I don't actually need the graph. It does say sketch the polygon, but I'd like you to try to sketch it on your own. And all you really need to do is calculate the lengths of each side to determine what kind of polygon it is. It's got 4 coordinates, so I know it's going to be some type of quadrilateral, but what type of quadrilateral is it? So first, let's work on distances so we can see if anything is congruent. So AB, whoops. So that's going to be 0 squared plus 4 squared plus 0 squared, which is the square root of 16, which is 4. So then BC is the square root of 7 squared plus 4 squared plus 5 squared, which is the square root of 90, which is also the largest perfect square that lives in there is going to be 9 times 10, so it's going to be 3 root 10. CD is going to be the square root of 0 squared plus 4 squared plus 0 squared equals the square root of 16, which is 4. And then we've got AD, square root of 7 squared plus 4 squared plus 5 squared, which is again going to be the square root of 90, which is 3 root 10. So I know right now that this is a parallelogram. Now, it seems like it's probably a rectangle. So if you recall, the way that you could do it is with slopes to get a 90-degree angle for equiangular, or you can do that the diagonals are congruent. So if we drew this, AC would be a diagonal. So let's find the length of AC. It's going to be 7 squared plus 0 squared plus 5 squared, which is going to be the square root of 74. BD is going to be the other diagonal, so that's going to be 7 squared plus 0 squared plus 5 squared, which is again the square root of 74. So now this is a rectangle. So we know it's a rectangle, and then the last bit of there says find the area. So if it's a rectangle, rectangles are just base times height. So the base in this case is going to be our BC length. Like if you think about just a regular rectangle, you know, you've got A, B, C, D. You could use the CD. It's really just going to be the 2 lengths times each other in either direction. So it's going to be, area is going to be 4 times 3 root 10, or 3 root 10 times 4. So then 4 times 3 is 12. Root 10. Thank you.